In this video, we are going to look at how to access character pointers and how to get their value. So it's pretty much again a basic tutorial about pointers, which is very important, I believe, because this is always causing some trouble among beginners in C-level language, so I really want to make you know all of the things regarding pointers. So here we go, and after this we are working with pointers in every video, I believe, so I can't really imagine any tutorial after this one that is working without pointers. So pointers are very essential to the C-level language, and of course in the basics we need to know where mistakes can be made, and this is one of the videos I want to show you some possible mistakes you could do with character pointers. So the exercise is pretty easy, and the first three tasks are just declaring a character pointer and initialize it directly with a string value, which is somewhat special, but not just special to characters, but the characters are maybe one of the applications for this one that makes most sense. And we have to declare a character array, which we already can, just a simple array, nothing to do with pointers, but we declare another pointer which will point to the first value of that array, the first index. And this is the first task, so I will just do this. The first character pointer, and I assign a value to it like this. So like I said, this is somewhat special because, as before we said, we are just assigning a memory address to a pointer, and well, we can easily see that this is not a memory address, but it's still working, and maybe we will get an idea of why this is working later on. Okay. And the second character is just an array. I will give it the same value than the first one. And the last one is a pointer again, which is pointing to the first index of the array. And we've already learned that this is looking like this. So this is already not very special for us. Okay, so the second task is print out all the values, all the three values here, which is also not very difficult, but has a surprising element, because we don't need to dereference the values. That means we can just access the values by just using their names, and we want to see if this is really working, or maybe I'm talking crazy things here. I will also put the WALL parameter to the compiling process, so you can see that we don't get any errors at all. This is important for something I want to show you later. Okay, we can see it's just working fine, and I will explain to you why we don't need any dereferencing here. But first I want to do the last task, and after we are doing that, it's easier to explain this. Okay, but I will start with character 2, because we already know that, and we should always start with the things we know and then get to the things we don't know. Okay, so we can alter the value of an index of an array by just accessing the index and assigning a new value to it. So I can just go here and say, okay, the value of the first index should be A. And of course this is working, and this is not very surprising, but I want to execute the program now because I want to show you something that also is not very surprising, but you should keep that in mind all the time, because we are not only changing the value of our array, but we are also changing the value of our third pointer, of course, because a pointer is just pointing to a memory address, and we changed the value of our string, which lies in this memory address. So, which is also why the output of our pointer changed, because we are just accessing that memory location. So whenever we are changing the value inside of this memory location, we are also, of course, changing whatever the pointer is pointing to, the value, not the memory address. Okay, and now we could go ahead and say, okay, let's try some funny thing, because actually we are just accessing this in the same way. So why can't we go ahead and say, okay, this is obviously behaving like an array inside of printf, and why shouldn't it behave like an array throughout all of my code? And yes, you're right, that's a perfectly great question if you come up with it, and this is working. So you see, we changed the value of our pointer, but really we changed the value of the array too. The pointer and the array changed again. And yeah, this is pretty much behaving like an array now, as you can see. So we can also just assign a value to it and just use it as an array, which is also not very surprising, because we know that we can print out the value just like an array, and of course we also can access every single character inside this string, and of course we also can manipulate every single character inside of this string. This doesn't mean that pointers and arrays are the same thing, they are not. But in this case, the character pointer is behaving like an array, and you can use it like an array. And this is yeah, very convenient when it comes down to array operations, which we are not using quite often, but maybe you are using them for learning purpose, just like now. Later we will build up some structures that are maybe a little bit more comfortable than arrays, actually. Okay, so what we've learned is character pointers behave like arrays. So we could think about, okay, our character 1 may be a very convenient way to declare an array, right? So if we can also alter this value here, we have a really, really convenient way to declare new arrays. But this is actually not working. So we can't go here and change the value of our character pointer. And why is that? The first thing I want you to see is this is not throwing a warning at all, but it will crash our program as we are making an illegal memory access here. So our program will just crash, and we don't even get any signs of a warning here. So you can do very, very bad things with C-level language, and I want to explain to you why this is crashing our program. The reason for that is this string is actually in the process of compiling, this string is actually written inside our program. So you know that every single letter is a number, and this number, of course, is somewhere in our program. I just want your imagination here. I don't want to give you a really good explanation for this, but an intuitive way to understand this. So every letter here has a number inside our program, and if we are trying to change this letter, we are trying to change this letter not only in our string, but in all of our program. So whenever if we could change this letter, whenever we want to print out an H, because this would change the letter H, it would actually print out the letter C, because we are changing the value of the letter inside of our program. This is read-only memory. And to prevent this from happening, they made this actually read-only. And now whenever we try to access a read-only memory, we are of course getting an error and our program will just crash because this is illegal memory access. Okay, so this is something we can't do. What we can do is we can access, give a new value to our pointer, to our character pointer. This is very different from this here, because this tells the program actually H equals to C, and it will change the value inside of our program of the letter H, and this is changing the complete value of our string here from the pointer. So this is just changing the pointer. So our pointer will not point to hello world anymore, but it will point to test, 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 or whatever you are writing here. So this is actually working. I will show this to you. And also another remarkable thing is that we can exceed our initial character count here, which we cannot do when using arrays. Okay, then we are already getting a little bit out of the exercise here, but I want to show you a little bit more about accessing character pointers. So just lean back and watch on, so you can actually get a little bit better understanding of accessing array pointers. Because you could ask the question, okay, what is happening? Printf, okay, what is happening when I dereference my pointer? So when I go at here and I say, okay, 3 or 1, doesn't matter. I will do this with 3 first, but later I will show this to you with 1, 2. It's just the same. They are behaving the same now. Okay. What happens when I try to compile this? You can think about this, but I am getting an error, because the problem is this format string expects a type of a character pointer or an array, which basically, like I said, is a character pointer. But our argument is of type int, and you can think about it like that. We are dereferencing the value of the character 3, and what is the value of character 3? Well, it's the first index of the character 2 array, which is why I start with 3 here, so I can show this better to you in a better way. So we are actually dereferencing the value of H, which is a character and not a string. So the character, of course, is an integer value in C-level language. We already know that. We heard that a lot of times. So we know as great C developers that this is not an integer value, but it's a character. So our printf is expecting a character, and this is the B, the first value of our string here, because we changed it to B. If we didn't change it to B, it would be VH. So what actually happens when we dereference our pointer here is that we get the value of the index the pointer is pointing to. And it's the same with character 1. If I put character 1 here, I would get the H in the case here, and I would get the T here because I changed the value of character 1. So I can save that and run it, so you can see that is a T here. And the thing now is we can put all of it inside of a while loop, and we can say, okay, or a for loop. For loop would be better here, but I will show this to you with a while loop so you can focus on the condition. If or while the character here is not equal to the 0 byte character, we already know every string is terminated by this value. So while this condition is true, print out my character, or each character in one line. Oh, I'm sorry, each character in one line. And after you print out the value, please go to the next character. We can achieve the next going to the next character by just incrementing the value. So the pointer will always shift to the next character. Okay, I will compile this. This will give us a warning, but we can ignore the warning. But we get unused variable warning because the C compiler thinks we are not using the computed value in any way, which is of course not true. So for you that means sometimes you can ignore these warnings. Yeah, and you can see I get character by character printed out on the screen like we saw in some exercise before, but this time we are using the pointer. So you can see this is maybe an intuitive way of understanding the dereferencing of characters and string values. So I hope maybe you tried to learn this before and maybe you understand it better now. You can just leave a message maybe, so I can know if this video was any helpful for you or if it was too much or whatever. And in the next videos we are talking about more complex structures which will build on the things we've learned now. Okay, see you in the next video. Bye.